Coding time. So Leetcode question, find median from data string. So in this video there are two goals. The first goal is to see how to solve this problem, and then we are going to do some coding work. And the second goal is to see how we should behave in a real interview. So let's get started. So remember, in a real interview, the first step is always try to understand the problem. If there is anything unclear, please bring up the question, and at the same time think about some edge cases. So let's read through this problem. Find median from data string. So median is a middle value in a sorted integer list. So if the size of the list is even, there's no middle value, so the median is a mean of the two middle value. So for example, 2, 3, 4 median is 3, 2, 3 median is 2.5. So design a data structure that supports the following two operations: add num and find median. So let's say if we add 1, 2, find median is going to be 1.5. If we add another number which is 3, then find median is 2. So I think I mostly understand the question. Let's see some. So there is some follow-up. So if all the integer numbers from the string are between 0 to 100, how would you optimize it? And if 99 of the integers from the string are between 0 to 100, how would you optimize it? Okay, so let's first think about how to solve this problem though. How to solve this problem? So essentially, of course, there is always some brute force solution. So for example, when you try to add a number, then you can do some insertion sort, find the corresponding position to insert the number and then insert it, and then find the median. It will be just get the middle number. So for that one, like brute force with insertion sort, let's say the add is insertion sort. The runtime is going to be all of n. N is the length of the array, or the numbers we have already added. And for find, the runtime is going to be all of 1. So I think find is for the find API. Find median API is good, but what we should do is we need to optimize the add num API to make sure that the runtime is lower than linear. So let's see how to do it. So actually, if you remember, we have a data structure called heap. We could actually separate the entire array into two different parts. So two parts. The first part contain, let's say if there are n numbers, suppose n is even, then the two parts contain equal numbers. Suppose and the n is odd, then sometimes the first part has but anyway, the difference between the first part, the size of the difference between the first part and the second part is never going to be larger than 1. So that's the guarantee we are going to get here. So we have the first part, I would say the first part minus the size of the second part is never going to be is never going to be larger than 1. So what is the first part and the second part, and what are the data structures we are going to use for that? So for the first part, we are going to use max heap, and for the second part, we are going to use a min heap. So the thing is, so for add number, if the size of each part is equal, then if the size of each part is equal, then it really depends on the comparison. So if the number is smaller than the top element within the max heap, then we are going to insert into the first part. Otherwise, if it is between the max heap, the top element in the max heap and top element in the main heap, then it could be either part. It could go either part. If it's larger than the top element in the main heap, then we are going to insert it into the second part. But what if the number of the elements within the first part and second part is not equal? So let's say if the first part has more elements than the second part, then we don't really want to add the number into the first part. We want to add the number into the second part. But sometimes, if the number we are going to insert is larger than the top element in this max heap, then we need to remove the number from the max heap and insert it into the min heap, and then we are going to add the corresponding number into the first part. So similar, like vice versa, we could potentially remove the number from the top element from the min heap, insert it into the max heap, and then insert the number into the second part. So we want to have, anyway, we want to have a balance of the number between the first part and the second part, and also we want to make sure that all the numbers within the first part is larger than the number within the second part. All the numbers from the second part is larger than the numbers from the first part. So find median if the size of the two parts are equal, then it is pretty much the top elements, the sum of the top of the elements and divided by 2. If the second part has one more element than the first part, then we are going to return the top element of the main heap. Otherwise, it is the maximum top element from the max heap. So having said that, the runtime for add number is going to be log n, and it's the number of the numbers we have already inserted. And for find median, it is going to be O1 operation. So for that one, we use the max our main heap. This approach for add is going to be O log n, and for find, it is going to be O log 1. So I think currently that's the best approach I can think of. Let's get started and do some coding work. So for coding, we care about the correctness of the code, the readability of the code, and of course don't be too slow. So let's define the max and min heap. So we are going to use priority queue here. So let's say priority queue. This is integer. I would say this is first half. So first half, remember this is a max heap, and the second part integer second half. This is the main heap. So for median finder, we are going to initialize it. So first half, let's say is new priority queue. So let's say it is initialized with one number, and the comparator would be num1, num2. Because it's max heap, then we are going to, it is going to be num2 minus num1. And for the main heap, we just need to use the natural order for it. Okay, so after that, let's call the find median, which is an easier API to implement. So find median if first half dot size is equal to second half dot size. So the thing I'm trying to think of, what if there's no number within first half and second half, but we are calling the find median. Is it going to throw an exception or whatever? So I think let's just make the assumption that we are never going to call find median when there's no number within the first half or second half. So then we are going to return first, say first half plus second half dot, I think it's like a peak, peak, and modular by 2.0. This will be, we change it to a double. And otherwise, if first half dot size is larger, then we are going to return first half peak double first half peak. Otherwise, we are going to return the second half peak. So second half peak. Okay. So that's the find median for the add number. We are going to see if so if the size is equal, then we will see, what we will see is we compare the number with max top element with the max heap. If num is smaller or equal to the first half dot peak, then we are going to add it into the first half. So first half dot add num. Otherwise, if it's larger than that, so if it is larger than that, we could if it is larger than that, we will just add it into the second half. Otherwise, second half dot add num, and we are going to return here. Otherwise, if the first half is larger, then for sure we need to add a number into the second half. But before that, we need to see whether the number is larger than the maximum of the first half. So if it is larger, then we just need to add to the second half without doing any extra operation. Otherwise, if it's smaller, then we need to pop the top element for the first half and then insert it into the second half. So if it is equal, then okay. So another thing is, if everything is empty, what should we do? So if first half dot size is equal to 0, so if it is equal to 0, let's say, so there is something special here. So if first half dot size is equal to 0, then we just need to have first half add num, and then we just return. And the other thing is, if first half dot size is larger than the second half, we will see if num is larger than the first half dot peak, larger or equal. then we could just add second half dot add the num, and then we just return. Otherwise, it means it is smaller, so we are going to have second half dot add first half dot pull, and then we are going to add the num into the first half, the num, then we return. Otherwise, it means the second half is larger. So if the second half is larger, then we will say if the second half is larger, we need to see if the num is larger, if the num is actually larger than the top element in the second half. If it is smaller than the, let's say if it's smaller or equal to second half dot peak, then we are going to say first half dot add the num, and then we just return. Otherwise, it means we need to pop. We have the first half dot add second half dot pull, and then we have second half dot add the num. Yeah, so that's pretty much it about the code, and it's time for us to do some testing. So let's say we initialize the priority queue. The first half is a max heap, second half is a main heap, and then when we add num, let's say we add num, first of all we add 1 because it's equal, so we are just going to add it into the first half. Then we add 2, and we see that the first half dot size is larger than second half. Then we see that 2 is actually larger than 1, which is the top element in the first half. Then we are going to add it into the second half. So when we call the find median, we are going to get 1.5 for sure, because the size is equal between the first half and the second half. So when we add 3, we see that the 3 is so the size of first half and second half are both equal, and we see that the number is actually larger than the first half dot peak, because 3 is larger than 1. So we are going to add it into the second half. So in the second half we have 2 and 3 now, and then when we call the find median again, we see that second half is larger, so we are going to get second half dot peak, which is we are going to return 2 that for that. So I think overall it works fine. Okay, so seems like it's working. Let's do a submission for it. Okay, so it seems like everything works well. So that's it for this solution. Let's see some follow-up questions. It says if all the integer numbers from the stream are between 0 to 100, how would you optimize it? So how would I optimize it? I could use a bucket sort here. Because it is between 0 to 100, I'm going to have 101 buckets, and each bucket contains the frequency of the corresponding number. So when we call add num, it is going to be 01 operation, and when we call the find median, it is going to be 01 operation as well, because we only have like constant number of the buckets. And let's see, for the second one, if 99 of all the integer numbers from the stream are between 0 to 100, how would you optimize it? So if it is 99 for sure, then we know so I think it's the same. So we could also use the bucket sort, and we count the we just don't store the numbers outside larger than 100. Because we know for sure that we have only 1% of the numbers outside of 100, so by considering the extra 1%, I think it's also easy to find the median, given that we know, let's say we have, so for example, let's say we have 99 numbers within 0 to 100. So it's for sure that we have one number which is larger than 100. Then from stream or between. Okay, so is it some? So if it is all positive numbers, I would say we have one number which is larger than 100, and it's easy for us to compute the find median. But what if it's allowed to have negative numbers? Is there any restrictions here? So middle of the value is the size. There's no middle value. Okay, it didn't say that all the numbers are positive. So in that case, I think one thing we could do is we could do some estimation though. So let's say if it is the probability distribution is quite even, and we assume that let's say we have 99 numbers, so it could be like we have the one which is smaller than 0, or we have the one larger than 0. But let's just omit it, and we assume that 99%, let's say like the number of the numbers smaller than 0 is equal to the number of the numbers larger than 100. Then we just compute the median within this bucket. So I think that will be my answer to the follow-up questions. So that's it for this coding question, I think. Then, so if you have any question about the puzzle or about the solution, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.